Hello students, Professor Smolny. Talk about Chapter 8 called Looking Smart, Maximizing Perception of Intelligence. So Chapter 8 is going to talk about some tips and tricks that you as an AI programmer or you as a programmer in a game could use so as to maximize the performance of the game while still giving what appears to be a very intelligent, very smart acting AI system. So how can we kind of cheat in different situations to save cycles, to save performance, but still deliver, the most bang for the buck. So the key chapter questions. What are two types of cues that can be used to make the intelligence of the AI apparent to the player, whether this is visible or audible? What are three techniques for optimizing the AI that preserve the player's perception of the AI's intelligence? What types of behaviors cause the AI to appear mechanical rather than intelligent to the player? When should cues be used to simulate an intelligent behavior instead of creating an AI system to perform the behavior? Varied strategic choices indicate intelligence to the player. Why may the AI appear less intelligent if it always chooses the best strategy? So at the very beginning of the chapter, the author talks about a program called ELIZA that was written in the 1960s that basically interfaced with a human being to hold a conversation. And ELIZA was very successful in fooling humans into believing it was a human. So much so that actually certain people gave away personal information. And I'm just going to digress from the chapter slides for a second to talk about the more general idea behind this, which is a Turing test, in which you know um, a computer is compared to a human being, and at some point, if a computer can perform well enough, another human being would never be able to tell the difference between the two. So in this picture over here on the side, you can see this is the person trying to discern whether or not they're talking to a computer or a human being, and they're actually talking to one of each, and they have to choose which one they actually believe to be a computer. So, and the idea is, there are, if a computer could actually hold a normal conversation, how would anyone be able to tell, whether they were human or whether they were a machine? It's kind of like one of those holy grails of computer science. So, with that in mind, what are some of these ideas that allowed ELIZA to be so successful, and other machines that try and pass the Turing test to be so successful that we as game programmers can take advantage of? Um, First and foremost, you need to make the AI visible to the player, right? They need to be interacting as if these are fully featured, entities, human beings almost, that will interact in the normal way. So ELIZA, it was a chat program, just like IM, where you could chat with the program, and so anything goes there. In video games, it's humanistic behavior. So having your AI behave like a normal human being, not like a supercomputer that knows everything that's going on in the game. Only implement AI that the player can detect. So this is one of those optimizations. You don't always need to have the best algorithm running for your AI. If it turns out that the character that's using this AI is off screen, you don't need to do anything. It's undetectable to the player. Why waste processor time on running a program that isn't going to actually add to the experience? Also, avoid behaviors that appear mechanical. So in the case of ELIZA, there was a standard response if it didn't understand kind of what the question was, or what the comment was that was posed to it. Obviously, having more than one of those will make it seem like, oh, this isn't obviously a computer. If you say the exact same thing over and over, it becomes robotic, and it becomes really clear to the end user, like, oh, it's a very simple system. It only has one response to this question. Um, show the player AI that makes the show the player AI that makes choices. So in this, what this is referring to is that have a multi-level AI, a multi an AI that's is capable of having multiple possible choices in what it does. So once again, instead of always attacking a problem in the same way, or always playing the player in the same way, or always conversing in the exact same way, allow your AI to have multiple solutions to the same problem so that it doesn't always choose the same thing. Human beings are not robots. They don't do the same thing every day. We don't all get up, eat the exact same thing, you know, do our exact routine the same in the morning. Every day is different. Your AI should be the same. Um, Give the player a reason to see more than is really there. So this is kind of some of that magic behind games, in that, at a certain point, we as human beings kind of believe that something is real. You know, so in the case of, you know, a movie, our eyes are tricked into believing like that's real, fluid motion when it's only 30 frames per second. There are actual gaps, but our eyes can't detect it, so we therefore assume, it's continuous motion. Same thing goes in video games, where um, people will believe that the systems are more advanced than they happen to be. Um, there's some great games out there that have come out recently where, based on audio cues, people think that, the AI is really smart, but it's really just a matter of them being fooled or duped by the game into feeling that way. And so what are those tricks that we can really take advantage of to give that really immersive experience without actually having to have a supercomputer to run it on? So make the AI visible. So here are two different examples of games in which, you know, through the use of audio cues, um, the player is meant to, or the player feels as if they have insight into what the AI is doing. So in this case, I'll talk about Perfect Dark Zero. The AI in that game will actually have some certain audio cues to tell the player exactly what state it's in. Like, oh, you know, enemy detected. Like, oh, I've been alerted to your presence. I need to go attack you now. Instead of just having, the animations or the actions that the character would do, just go over the top and make the player really feel like, oh, I've just been detected. Like, give them every possible indication of that. Um, Makes them feel like the AI is smart, that they're actually having more dynamic interactions with them, and gives them better feedback. Part of AI um, and part of a good game is having a good feedback loop between the player and the machine. If the player feels like they're not connected, like the actions that they're taking aren't directly affecting the system in front of them, then they're going to feel less um, involved in the game, less immersed in the game. Whereas if they feel more attached to the game, they're going to want to play more. They're going to be less likely to feel like they're taken out of that experience, taken out of the game. And so anything that you can do to heighten that always is the best thing that you can do. Considering how much you have available to you as far as processor resources. Audio cues, really simple things to put in, not a lot of processor power required to play them, and basically the return on investment is really great. Now the flip side to that is eliminating invisible AI activity. So you know if there are AI units that are off screen, by all means feel free not to use them, or not to update their state. I mean, it's undetectable to the player. Maybe you need to do some low level things, but you don't obviously need to be rendering those units. You don't need to be thinking about state transitions for those units. Um, and so you can save a lot of activity there. Now, that said, everything that on screen has to be performing correctly. Um, you can also um, think about other ways in which you can do this that can also improve your efficiency. Um, so maybe there are partial optimizations. So things where the AI player is way off in the distance, you can use something called an LOD, which is a level of detail. Common use term. Basically what it means is you have varying tiers of um, complexity in both your